So let's get started. We are recording and sharing. Okay, so we're good to go. So starting with Koin. And I'm not going to look at the camera though very much because I'm on a monitor. But feel free to stop me if you have any questions or if I'm going too fast. So just shout out. So the first thing for Koin and with anything is that it's third-party dependency. And so you have to bring in your Koin library. I mentioned this on Friday is that I threw these projects together really quickly over the course of a week. And so like, obviously you can notice that I have some cleaning up to do. My dependencies aren't up to date. I could go through, but I was just like pulling things I knew from other places and anything that didn't matter, I just like left it as is. So please ignore some of the housekeeping I need to do in this project. So Koin only requires one dependency. We have just our one Koin Android view model in the Koin version, which also needs to be updated. And then the first step in dependency injection is updating our application class. So we extend the application class and make our main application, and that's where we're going to start our Koin. So anytime you override your application, you also have to update it in your Android manifest. And so in here, we can see that my application has my app.main application in here. So back in our main application, we start our Android or our Koin by passing in the context. Context is really important in Android. You need it for everything. So we immediately pass that in. I'll talk a little bit about those file properties when we go into the modules. And then the next thing that you do is you add all your modules. In this particular case, I only made one module, and we'll go and look at that next. And so I just pass in that one giant mega module. Whether you separate those out or not is kind of a personal choice, like so many other things on Android. But if I wanted to break it up into like different modules, so like a networking, a database, a view model module, you can do a list of here and then just pass in your different modules that will all be of type module. And then behind the scenes, they combine them and do it all the same. But for organization purposes, you can definitely pass in a list there. So I put together some modules that I thought were pretty common and so I hit a networking class. I guess I could show the app. I can show you what this app does. It's a really simple little app. It's one screen. It fetches my commits from a different repository and then displays them in a list. And so that's it. It's just that one network call and some data binding to make it all pretty in front of the scenes. And but that's it. That's the whole thing. And so here I have some of the services I'm going to use. And then I also made up some extra services and extra variables to show some of the testing. So I have put this code out in the WWCode Slack. So if you go in there and you're like, what is this doing here? It's doing nothing. It's just for testing. So the way I like to think of dependency injection is the wiring behind a light switch and a light. When you think about turning on a light, it just automatically happens. You just push a button and then it's there. But behind the scenes, right, there's a lot of wiring that says, okay, now this happens and this needs this. And that's what dependency injection does. It wires up all the things you need behind the scenes so that all you have to do is say, hey, I need this right here, right now, and Koin just like hands it to you, or Hilt can also just hand it to you. It's the wiring that goes on behind the scenes of your application. So the two main types of modules that you have inside the Koin framework are the singles and the view models. So singles are things that you're going to share throughout your app, and there's only ever going to be one, and then view models are things that are type view model in Android. So that can be either the Android view model or the regular view model. So the couple of singles I have that I wanted to display, or I have a service. I also have a repository. I have a database, and then I have a log service, which is completely pointless, but you will see why I built it out. So if we look at my GitHub service, and I'm assuming that most people have used Retrofit at some point, I have my retrofit instance, and then I also have a factory to build out. Retrofit follows a builder pattern for both the client and the retrofit service instance. So that's all my factory does. It takes in my URL, it builds out the client, and then it builds out the retrofit instance with that URL, and then it returns that. So if I jump back over to my modules, I call that factory method, my .create, and pass in the API endpoint, the base URL. So this is where if I was making a real app and was doing all the best practices and was hiding all my strings instead of hard coding them here, I might use my Koin properties. And so the Koin properties is similar to like a strings.xml, and where you just give it some kind of ID and then pass in the value that you want. So I could define my GitHub endpoint API, or my GitHub API endpoint in my Koin properties. I would pass that Koin properties into my start Koin, and then in here I could call Koin properties.get property, whatever that ID is. And so that would probably be a better thing to do. And I might go back into and push that change up to hide that inside the Koin framework. And again, just do it a lot like how we handle strings in Android. My log service is a really, really, really boring service that says do nothing all throughout it. It's for the testing, just to show some different things you can do. But again, a lot of people collect analytics and that sort of things in their apps. And so that would also be a single that you could share throughout your whole app. My main repository takes my GitHub service. And so I followed a very MVVM pattern for this. So I have all my modules, and I have my service, and I have the repository on top of it, and then a view model, and then a view. And so this is the first instance that we really see dependency injection in Koin. So I have this main repository, and it's going to depend on my GitHub service because that's where I'm going to make that network call. And so in my constructor for my main repository, I have my private value GitHub service. And so when I pop back over to my modules, you can see that I'm using that named variable GitHub service, and I just have to use the getter that Koin provides for me. So that is like the most important thing that you need to understand about Koin, is that you just have to call all these getters everywhere. It builds out all these special getters for everything inside this module class. So I have a single that returns type GitHub service. So just like when you see Lambda functions, it has that final line as the return type. So my GitHub service single is returning of type GitHub service. In my main repository, hey, I need something that is type GitHub service. Hey, I have something that just returns that. And so this getter wires up that single that returns the GitHub service and this single that needs a GitHub service and starts building those dependency wires underneath the covers. So I'm not using a database for anything in this particular application, but again, it's something that you see a lot as room databases. And so I decided I would throw you together a room database so you can see what that looks like, because it is really common. So room databases also follow a builder pattern. And so I pass in my Android. We can jump in and look at my very boring main database. It takes on a room commit. I only used commits in this whole app. And it has its commit data DAO and an empty list of migrations. So this similarly is the exact pattern you see when you look at the room examples. You pass in the Android application, you pass in the type of your class, so mine is main database, and the name. And then I can apply my migrations, should there have been any, which there were not, and then I build it. So that will return me a room database. That's a really important one, probably more important than the other ones to be a single, because you want all your data to flow into the same database. And so that one has to be a single so that you have one instance of that database everywhere and all your data is in the same place. So anytime that you call for that database, you always get the same set of data. So that's the background of the app. And now we can jump into the MVVM part and look at this view model. So jumping over to my view model, I pass in my main repository because I'm going to call for that fetch commits. And then I also pass in my log service because I'm going to log out my network calls. If we looked at that, we could kind of see what I was planning to do with it. I have a network attempt, I have a log success, and I have a log error. And so those are the two dependencies I have here. And then of course it is of type view model. So back in our modules, now I have this new type from Koin, and it matches what my type is. And so it's a view model type. And again, it does exactly the same thing. Koin is really systematic about the matching and pattern. And so once you get a couple down, you can do them all the same way. So I personally use named variables for especially for Koin modules, because otherwise it's just a bunch of gets everywhere, and that can get really confusing really quickly. So I use my named variable main repository get and log service get. And so again, we can see in this, it would yell at me if it didn't have something that had that returned that type. So I have a single that returns main repository, and I have a single that returns a log service. And so all these dependencies are in this file, and it can go and get those for me and wire those all together. So that is building out the main view model. We'll talk a little bit about what it's actually doing here before we do the testing, but the final step of like getting all of your dependency injection set up is the next level up and back into the view. So I have an activity, it's very boring, it doesn't have anything, and it doesn't need anything because it's not doing anything. But my main fragment is using my view model. All my logic is in my view model, and all my handling of my view is in my main view model, or is in my main fragment. So right here is where I inject my view model into my fragment. It just is by shared view model. And in this case, I had just changed it for last time. I have this type over here in the caret brackets. But my usual method of doing it is I get rid of this and I add my type behind it. And then I can also do by shared view model. So that was just a comparison of the two different ways that you can tell it what type of view model it's going to go and get for you. So that shared view model is, there are two options for how to get view models inside your fragments and activities, is by shared view model or by view model. So just like anywhere else in Android, one view model can be shared across a single activity, but in any number of fragments. And so the shared view model means that anywhere in that activity, it will give me the same view model. So the data will be the same, anything set in there, the variables will be the same, it will be the exact same view model. I can also just do by view model, maybe. Maybe by view models. I don't use this one very often, but there's something kind of like that. You'll have to bear with me and never live coding anything. But there is by view model, also by Koin, and that will give you a new instance of that view model anytime you see it. So if you do it in two fragments in the same activity, it'll be two different versions of that same view model, so that data won't be shared across them.
So I think, Sierra, you were doing it right. It's just called activity view models, the only view models you were trying.
Oh, so this is activity?
Yeah, activity view models. When I say it in my project. But I think you need some different API or something for it. Yeah.
Yeah, so I don't use that one very much, but I do know it exists. One thing that I always liked about MVVM and view models is that I could share it across your fragments, so I never really saw the point of making a new one between. It is something you have to watch out for, though, that if you, even though you have this shared module, if I made a second activity and called this main view model inside of it, it will be a different instance. It will not have that shared data. So that even if I call by shared view model, it will create a new instance for that activity. And then any fragment in that will have that new instance. So that is pretty much data binding from the ground up in Koin. Do you guys have any questions about that?
So I have one question. In this main application class, oh, not there. Then, where did you declare that those single and
The modules,
view
yeah.
model? Yeah, modules. Yes. So can we have multiple repositories in this single scope?
If you wanted to make a different repository, you would just have to make a different single.
Different single, okay, but not
but it can't be
combined.
the same type because it can only make one of that type. Yeah. I could certainly make a secondary repository and also make that a single.
Okay. So in case if it's a huge project, then if there are a lot of repositories, so this will be the actual place where we'll go on adding all those repositories, and database will be just one, but view models too.
Mm-hmm.
Yeah, got it. Thanks.
So if you get to a huge project, you might want to consider breaking out your modules. I will say I am guilty of having a pretty large module list and we just keep adding to it. So you can definitely do it. But it's definitely personal opinion of when you call it quits and decide to do some refactoring.
Okay. So we can have more modules there.
Yes. And then when you do in that start coin, you just pass in list of, and then you pass in all your modules. So mine in this main application is just the one because I only have that one object modules, but I can pass in a list there. I can pass in more than one modules.
Yeah. This is cool.
So in case of multiple modules, can we have like dependency of one module to another like we have in Dagger? Can we do that?
You can, yeah. So Madona's on this call now, and I know that her project, they break out their database into one module and then all their view models in a different module. And so they have to cross-reference between those as they pull in the dependencies from that database module into their view model modules.
Yeah.
She's here, she knows.
Thank you, Sierra, for doing this. This is so awesome. I think I had a very different question. I know I know this is awesome, but I also wanted to ask a question like in terms of now the view models, right?
Mm-hmm.
So I don't know how I'm going to frame it, but I'm kind of like seeing a lot of RX from my previous work and now my current work, but it's RX Java.
I don't know if I can answer questions about RX Java, but I will give it one shot.
Yeah.
Been a while.
I actually wanted to talk about that because I was thinking, so I tried coroutines and I think they do the same thing. So I wanted to hear like your view, because I feel like if I understand your view more, because we have a new app that we're building, maybe I can try to convince them to use coroutines somehow. So what do you think are the best advantages of coroutines?
My number one argument for coroutines is that they're built into the language and it's not a giant third-party dependency.
Mm-hmm.
And like that argument alone, I think should get enough companies to switch to it because nobody wants extra third-party dependencies.
Yeah.
But I also think it's a lower learning curve. RX is a really, really steep learning curve at the beginning to connect all the pieces together, right? Understanding what a subscription is, understanding what the observing is, understanding what to subscribe on, mapping
latest.
And so it gets messy quick. I have certainly done my fair share of times where I'm just like switching between like mapping and flat mapping and to observable to just try to like get the return type to be what I expect it to be. And so RX is just hard to read. It's hard to debug. I think coroutines are a lot easier to debug because you can just like, there's not those chained functions in my opinion, right? It's really annoying to like debug a bunch of chained functions where they're not just like going step by step. They're very readable. You're like right down to it. I have one here we'll talk about in next. But like readability, debuggability, not a
Mhm.
third party, those are like my top arguments for switching to coroutines. I'm sure you could find more passionate arguments online, but for me,
Yeah, because
like ease of
I,
use.
because I
I
feel
like
the
being
same.
lazy.
No, it's not. Because I think I've tried coroutine a couple of times and I'm comparing it. It sounds more doable compared to RX. I don't know. I just feel like
It
it's
is.
more,
I think that
yeah.
everyone for the most part agrees it is.
Because now like I'm working on trying to exit a dialogue and it keeps leaking and I'm thinking it's because of this combined latest thing that I'm doing. So it's a mess.
Yeah. I actually think that combined latest is one of the only things that coroutines and people online would fight me on this, but it does not, there's not a great way to do combined latest unless you write your own combined latest, because coroutines by themselves just like fire off in order. And so one nice thing about combined latest is that it fires them both off at the same time and then waits for those to come back. And so you have to write something to make both fire off at the same time, because if you just put both in a coroutine, it will send one off, wait for it to come back, send the next off, wait for it to come back. And so you can like double the time that that's going to take versus it like shoots both off at the same time and then waits for them to come back.
Okay.
But we can definitely talk about that somewhere else.
Yeah, I'm going to let you
because
continue.
I have written something to help with combined latest and coroutines.
That would be awesome. I'm going to let you continue. I'm going to listen in. Thank you very much for answering my question.
Yeah. So I mentioned that this app is just a bunch of data binding. So to talk about the tests, we need to like talk a little bit about what I like shoved in here. So my list commits is data bound to the button on the screen. And so when I click that, this is the function that immediately fires off. So the first thing that happens is I just log my network attempt, calling that very, very silly log function that does absolutely nothing, but it does make the network make a function call. And then I do start a coroutine. Retrofit recently added support for coroutines, so it's really nice and really easy now to add retrofit and a coroutine. You just have to put suspend on your retrofit function. So if we jump back over to there, you see the suspend. It knows it's going to be called from a coroutine, and it makes it so pretty, right? That's just another suspend function, and then all the way back in my view model, I launch that coroutine inside my view model scope. So then I post loading is true. That makes my spinner spin while it's gone. And then I have this allow network call. It's a piece of mutable live data in my main repository that right now is just hard coded to true. Again, a very silly little variable for us. And then I make my network call. I log my success. I post it to false, and then I post my results. That's all data bound, and magic happens, and now it's on my screen. So that's all that happens. I also have a failure case that logs an error, has an error, does some values, and that's about it. So again, just a super simple app. So now I want to hop over to testing, and in this I am using Mockk, M-O-C-K-K, which is Kotlin first. And so I wanted to show some of the things that some of the like coroutine features of this particular testing framework. So in my main view model class, and I only tested one of these class tests last week, someone made me run it with my coverage, and it is really bad, but it's really good in this one class. I'm going to test my view model, and so that's the only thing I'm not going to mock out here. So I have my private latent var, my main view model, and then as we know, that main view model has two dependencies, and so I have mocks of those two dependencies. So I have my main repository mock and also my log service mock. Because I am testing coroutines, I have an instant task executor rule just to make it go immediately so that you don't have to actually wait for things to happen. So my app before, if you have done unit testing before, obviously runs before every test. So it's what sets up everything. And so those are things that you want to have happen every single time. Because I'm using Mockk, I have to call Mockk annotations.init. And then I have some of these everys, and then the important part, well, everything's important, but I'm making my actual view model. So I'm setting my variable here. So I have my view model, my main view model, and if you notice, there's no actual dependency injection. This is completely separate to dependency injection, is I'm just passing in these mocks. So unlike over here, and when I'm using it in the actual app and I'm depending on Koin to pass those in, here I'm making a mock and actually passing those in and calling that constructor explicitly. So inside Mockk, you have a couple different functions, and we're going to use all of them. So every is things that are going to happen every single time, and co-every is something that's going to happen every single time inside a coroutine. So I have this log service, and it doesn't do anything, and so I don't need to ever mock it out as anything besides exactly what it is, which is why I'm putting it in my setup, because I always want it to do the exact same thing. So I have, if I jump over and look at this, I have my log network attempt, which is returning a Boolean, and the other ones that are just unit functions and don't return anything. And so that's just to show the different ways that we can set these up. So for my every log network attempt that returns a Boolean, I have returns true. So it always returns true, which isn't super helpful right now because it was already always returning true. But if that function were to depend on something, I can just say all the time, I don't care what that is. I'm not testing the logic inside that function. I just want you to be true all the time and always work. Similarly with log success and log error, since they don't return anything, they have, every time those get called, they just run, and we just skip on over them. They successfully run, and we can move on to the next line. I could also put these everys in every single test case individually. This just lets me type it once because I'm not testing anything there. If there was logic in there, I could write a different test and test that logic. And then in here, I can just skip over it and let it do what it needs to do. So my test in it is just to show that you still have access to all those JUnit functions that we all know and love. So not null equals assert true, assert false, all just from the JUnit assert library. Also like pretty silly little things to test, but again, to demonstrate everything that you can still do. So asserting that my view model is not null. Of course it's not. I just made it in the before. I have my username and repo hard-coded beforehand because I didn't want to type it out because I'm lazy. And then all my initial variables, I can assert those also. So then I wrote two tests, and this is where all those made up variables come in, is I have my test success case and my test failure case. So the happy path for this commit is that I log a network attempt, loading is true, allow network call is true, it makes that call, it returns a result, it logs a success, loading is false, and commit is now posted. And so that's exactly what I test in my test. So the first thing I did in this test is I set up the things that should just return when they get called. So the two things that I have here are my main repository, noting that I have already set up this log network call and this log success in my before. So I've already said, you're gonna run every time. I'm not gonna set you up every time because I'm never gonna test anything different. So the two new things I have to set up that I want to change between these two tests is that I have my main repository.allow network call. And so in here I say, every time you see this in this particular test, because it's scoped to this test, you're going to return true for that. And so that's gonna put me in that success path. And then I know that I'm going to make this list commit call. And so I also have this co-every. When I see this, no matter what I pass in, I return this list of fake details. So we note here is the use of that co-every that I talked about a little bit before, is now I'm in a coroutine and calling a function from it. And so instead of every, I now have to call co-every compared to some of the other ones. So I also use any, which is inside this framework. I assume it's inside JUnit, but I actually don't know that for sure. But in this case, because my variables are hard-coded and I'm not changing anything, I could put in Sierra O'Brien and Hacker News as a variable and then it would work. And if I put anything else, it would not work because those aren't what is in there, and it would call unless I post it specifically to those variables. So then I call the function that I want to test. So viewModel.list commit, and then it hits this. And so it immediately verifies that my log network call is going to get called. I assert, and then it goes inside here. Since I already know what these are going to return, I don't actually verify those because I am personally saying, hey, this is what you're going to return. I don't really need to test that because that's a silly test to say this thing that I say is going to happen is going to happen. It's just to put me on the path that I want. So I know that that's going to call and return, so I can assert that now my commits is not null because it's been posted. I know exactly what's going to be there. So this one is a pretty silly test, that it is going to be what I expect it is. I can co-verify because I am now inside that coroutine scope, that my log service will log that success, and I can assert that is error is false. So you see the difference between some of the co-everys and everys, and also the co-verify versus verify, depending on where you are in your code. And those are the main features of Mockk, and why I think most people will probably use Mockk over Mockito is because they have all these co-verify, co-every to test specifically coroutines in Kotlin. So then I also wanted to set up a test failure case, and this is why I made that silly allow network call, because inside my test case, I can tell it exactly what to return. And so even though it's hard-coded in my app, so that the app itself always works when I push that, here I'm gonna tell it, nope, now you're gonna return false, and you're gonna force me to go into that error case. So the first thing I do is tell it, allow that network call to be false. Then, because I know what should happen, I'm not going to mock out my list commits, because if that happens, I have bigger problems. And so I take out that return type. It wouldn't do anything to leave it there. It's totally fine, other than it's not going to be used. It would just be a pointless mock. So this one, I wanted to show this use of the word exactly. I know that Mockito has a specific like never gets called function. I know that they use like whenever this dot return. It's been a while since I used it, but I remember some of the syntax. And this exactly is the way that Mockk checks whether or not something is not called. So verify exactly 0 or co-verify exactly 0 means this should not be called. So in this case, I verify that my log service calls that network call attempt exactly once. I put that in there for like a case where you wanted to try 3 times before you gave up completely. So you try your network call and you're like, oh, maybe that was just a failure, let's try again. And so you could say, oh, try exactly 3 times, and then you can test it by saying verify exactly 3 times that tried to log a network attempt. Then, since I am putting false there and I skip over that list commits, I can do exactly 0 for that test. And so that confirms that that list commits never gets called for any username in repo. And then in this case, since that doesn't get called, there shouldn't be anything on my commits.value because it is mutable data. So the value of that mutable data, live data, should be null. So I assert that's null, and I assert my error is true. So that is kind of different things that you can do with this particular testing framework. Do you guys have any questions on that? I think this gets you a good starting place, like no matter what kind of things you're testing. I tried to like cover all my bases for different types of verifying and everys. So if we're good with that, I'm going to switch over to my Hilt app, which, fun fact, is exactly the same. So it's the exact same app with the exact same functionality. I did take out some of those extra variables and just not add them in because you saw it once, you don't need to see it again. Yay! So this is just like the very base case of what you need to do for Hilt. As I've mentioned several times, to keep expectations low, I learned Hilt last weekend when I wrote this app. And I have a page of notes right here. So we're gonna do our best shot. This is my first go. So please be nice to me. And let me check my work Slack because someone just messaged me. Make sure it's not important. Okay, it's not. Yes. Okay, so similar to how we got started before, Hilt requires more dependencies in your Gradle. It doesn't require this many, and I'm gonna go take them out, but again, haven't had time to do it because I'm so busy sometimes. There are a lot available, and I'm not totally sure what all of them do, but this was literally everything because I was just like trying to get this work, and so I was like throwing everything in here. But I think I only need this Dagger, this Hilt Android, this lifecycle view model, and this Android compiler. And then I also need to pull in this fragment, and I'll point out why I needed that. I think that if I updated some of these dependencies, that would go away and would just get eaten up by something else. But I was getting frustrated, and I knew I needed it, and I couldn't figure out what was needed to be updated to make it work. So I'll point out where I needed that, and we'll go from there. But you do need more Dagger Hilt dependencies than we did for Koin, which was just that one. So the steps for adding Dagger are somewhat similar. Let me expand on these so I can get around quickly. So again, the first thing I'm gonna do is go and touch my application class. In this case, instead of doing the start Koin, I just have to add my annotation at Hilt Android app, and that's it. So we do have to we get to take a little bit out of that application class, but again, I changed my application, so I need to update it in my manifest. So step 2 is to annotate your fragments or your views. So in my fragment, I have my @Android entry point. So @Android entry point, and that can be added to anything, to activities, fragments, views, services, and broadcast receivers. They do have to be Android X, so they have to be the latest and greatest Android. And then other things is that in this case, my fragment is inside my activity. It's the exact same setup. So I have one activity, I have this one fragment. And so because I need dependency injection inside this fragment, I also have to add that @Android entry point to my main activity that this fragment lives in. So because this fragment is dependent on this activity, both need that annotation. You need it anywhere where you need dependencies, and you need it anywhere that they're related. So anywhere in that hierarchy. So once you have that @Android entry point, you can use the @inject inside those. So I actually didn't because I was not following something that needed that. But now that I have this @Android entry point, I can use @inject inside of here and inject things that I need. I can also do it inside my activity because it also has it. For things that are @inject and you use that annotation, they have to be public. They cannot be private variables. So this is actually where I needed that fragment updated, is to get this by view model. So similar to Koin, I have by view models, and that's also available in both the activity and the fragment. And whatever my dependency of fragment was before I added that, it was not right and it did not exist. And so that was really important. So I, again, have, you saw I was doing NVDM. The Google Code Labs for Hilt has an example with a service, I think, and they use the @inject. So that's a good place to look at that example. And this is hopefully a good place to look at a view model example inside of a fragment. So the next thing that we have to do is we have to define our Hilt bindings. And then we can use @inject and constructors to take advantage of those. So So the way that the Hilt documentation goes through, it kind of goes top down, where before I was going bottom up from the modules up to the fragment, and they kind of go from up in the views down to their modules. So we're kind of going in the opposite direction. So anywhere that you can access your constructor, you can use @inject. So if we jump into my view model, this one does not have that log service, so because that was a completely empty service, so it's just thrown out, and this one, it does not exist. So I have my @viewModel inject into my constructor with my main repository. So the main difference here is that there's a lot more annotations in Hilt than there is in Koin. This is a little bit smaller, but it's the exact same code. It just took out some of those extra variables that were mostly used to demonstrate those two different test cases. If I go down one more level and into my main repository, I have the normal @inject into my constructor, and then I just have my GitHub service. So both of these I have access to my constructor when I'm building them out, and so I can use the annotations and don't have to use a module to get those bindings together. So the modules is where you put everything that you don't have access to a constructor and can't use these @inject, @viewModelInject annotations. And so that's going to go with things like third parties and also interfaces and things that you can't use a constructor for. So at runtime, what happens is it's going to take all your dependencies, so all these modules and all these annotations, and build out your dependency graph. And that is where all those really confusing Dagger errors come from, is they're trying to make sure that everything you need is there. So the first thing it does is build out these dependency graphs. And so it takes these modules and makes sure you have everything you need. So contrasting to last time, I did make 2 modules for this Hilt example. I think it's more common. Maybe I'm just uncommon with my Koin and single module. So I have my network and my persistence. So I have my my GitHub call, and then I also still made a database for this example also that I also still don't use. And so the one thing that I have in here is that I'm only using third party. So Room is a third party. Even if it's an Android third party, it's still a dependency you have to pull in, and Retrofit is also a third party. And so what you'll notice here is that I always use the @provides annotation. Whereas if you're using something like an interface where you also have to build out a Hilt module to access its constructor and build it, you will use the @binds. So this is @provides. There is similarly an @binds inside Dagger. And so those are the difference between those two, is basically third party or internal. So one that binds things already in your app together, and one that provides from a third party. So everything I had was third party, so it is what it is. You're stuck with it. So that's that note. So then there are, again, just a lot more annotations in here. So anything that's a module, you have to annotate with that module. Before we just did the object file equals module. So this is annotated with that module. These other 2 are the @install, which is new. I don't think that Dagger 2 had it. And then also your Singleton. So you have a lot of options for where you want to install your Dagger modules. I picked terrible examples for this one when I was building it out, as both of mine are installed in a Singleton component. Some of the other ones that you have access to are an activity component, view model components. You have a fragment component, a view component, a service component. So really just like all those things that you can bind to that Android entry point, you also have a component that those can be installed in. So if you install it in the activity component, for example, it will be available to all your activities. The Singleton component means it's available to the whole application. So it's tied to the application itself. So again, like we were talking about with Koin, when it means you want one for the whole application, that's when you use that @Singleton component. But if you had like an interface or something that you didn't need exactly one for everyone to share, you could use one of these @activity that shares just with the activities @fragment component that shares just with the fragments. Specifically around your question and providing more than one of the same thing, they have better support for that, or they just have better documentation on their support, and I've just never looked into it for Koin. So some of the other options that you have is if you want to, I'll jump over to the network module because it's a better example. So around these retrofit instances, you could have more than one of the same thing. If you have 2 different endpoints, you would return something that was of the same type because they both need an OK HTTP client, and they both will return a retrofit instance. And so you'll have more than one of those. And so they have some annotations to help with that, where you annotate it with a retention type. I actually kept the code up here because I didn't have a good example for it. So you have these qualifiers for retention types, where you have 2 different, they also use an example of OK HTTP clients. And so you can add these retention qualifiers on it. And then when you need to tell it which one you want to use, you can it builds out a new annotation for type. So they have this example between an auth and an other. And so now when you want to use those inside the module, you can add the annotation externally above the provides, or you can also do it internally in front of your variable when you pass it in. So I thought that was really cool. And that annotation continues up. And so you can also do it inside your constructor using those annotation types. Or up in the class, again, using that, they have an actual example of injecting, whereas I just used by view model. And so you can use that annotation all the way to the top. So now we're basically back down at the bottom. So this is where I build up my repository. So I need my client, and then I give my client to my retrofit instance, and then I give that retrofit instance to my service, and then I give my service to my repository. And then I have access to constructors all the way to the top. And so I can just use the constructor annotations. And then also my persistence module, where I'm building up my database. I make my database, and then I provide the commit DAO should I need it, which I don't. So that is pretty much it for Hilt. The documentation I thought was really readable, and so I basically read it to you just now from this notepad. I did want to also jump over to the unit test again. They're a little bit more simple because I didn't force it to ever have a failure case. But as you can see, it's set up almost identically, which is again because it doesn't actually use dependency injection in that. I make this Mockk version of the repository and then I pass it directly in. And so I don't depend on my dependency injection framework to make my test work, and I can have an identical test in both cases, and they both work. So that is it for my Hilt demo. And so now, do you guys have any questions on that I may or may not be able to answer?
So Hilt is a wrapper on Dagger, right? Kind of.
It is, yeah. I think that Google started seeing people switching to Koin really quickly because Dagger 2 still didn't solve our intense hate for how much work we had to do to set it up. And so Hilt is their new answer to that. And it uses a lot of the same Dagger components. A lot of things that you pull in, you'll see it's in the Dagger library.
So does Hilt play well with Dagger? Like if both exist in a code base, will that cause issues, or is it smooth, or what's the...
I'm not sure. There's a lot of documentation from Google to update your app to Hilt. And because they use so much of the same annotations, I think that it'd be really easy to switch from one to the other. But I don't know the answer of if you can use both at the same time.
Because we have like a modular structure within our app, like we have dynamic feature modules as well. So maybe to get started,
Yeah.
could have replaced, if they do play well, then we can start by replacing it with Hilt and just one module initially, and then take it from there.
Yeah. I can look into that and drop a link in the Slack, because I don't know. And that's a great question that I don't know the answer to.
Nice. Thanks, yeah.
Yeah. So I'm just gonna stop recording.